So our next speaker is from a very large startup called GE. And he is involved in a very interesting area. Obviously, we've heard of IoT. He's taken it one step further to say the Internet of really important things. So managing human interfaces to the industrial Internet and all the data and other things that go around it. So I'd like to welcome Greg Petroff.
Good afternoon, everybody. It's a delight to be here in front of the audience, talk a little bit about what we're up to at GE. And our presentation is really about this Internet of Things, but what we like to call the Internet of really important things. And there's a lot of conversations in the industrial world around what does the Internet of Things mean for that space. But the thing to recognize in the industrial world is that we have all these critical assets, the machines that operate our infrastructure. So if you think about how you arrived at the conference, you probably flew on a commercial aircraft. There's a 55% chance that that aircraft had GE engines on it. If you took a rail line here, locomotive, there's a 75% chance, at least in North America, that it was pulled by a GE locomotive. If you find yourself in a hospital, there's a very likely chance that if you need imaging, that the technology that's used to do that is an imaging device created by General Electric. And what we've discovered is that there's a huge opportunity now from a computer science moment to make those devices, those systems, the infrastructure that powers the world more effective and more resilient. So let's get into the presentation a little bit. This is the nacelle of the world's tallest wind turbine. It's about 300 feet up in the air. We have people who have to work in these kinds of conditions. Infrastructure is not always placed in convenient locations. So you have oil platforms that are out in the sea. You've got wind farms that are in remote locations. We have to build systems and technology that allow us to connect to these devices and these machines in meaningful ways and capture information off of them. Now, GE has been building sensors into its technology for years. In fact, most of the sensor technologies that we take for granted probably came out of GE's labs over the last 50 years. It's nice that they talked about us as being a 125-year-old startup. But until this moment, until in the last sort of 4 or 5 years, it's been almost impossible to keep all the data that comes off of machines. So we'll talk a little bit about that right now. So the Internet of really important things is a much different world than what we're seeing in the consumer space. So this isn't really about making your toothbrush connect to the Internet. It's not about even in your Nest thermostat controlling the environment in your house. This is about 20 billion things actually connecting to the Internet. The infrastructure, the equipment, the systems, and there are all kinds of good reasons why we want to do that. And what's phenomenal about this space is the volume of data that's going to be generated. And we're talking about exabytes of data. Now, if you look at the LEAP engine, it's the newest engine from GE for aircraft. The LEAP can generate up to ½ terabyte of data per flight. And if you think about every day in commercial aircraft, there's about 22,000 GE engines flying around the world. If they're all generating ½ terabyte per flight, that's a lot of information. Now, we're in a very interesting moment because we're in this moment where, from a cloud computing perspective, computation is nearly free, storage is getting to a point where we can actually capture all this information. And it makes sense for us to capture the information because we can actually start to understand the behavior of devices in ways that we couldn't anticipate or understand before. And going back to the aviation example, there are different airlines in the world. They behave differently. They may have the same aircraft, the same livery, the same engines, but the way that they operate their aircraft and the locations that they fly in could be very different. They could be in environments where there's sand in the first 5,000 feet of air, like flying out of Dubai. Or they could be flying in North America where the air quality is pretty clean. They could be flying long-haul flights where the distance is 12-hour, 14-hour flight. They could be flying from San Francisco to San Diego, and it's an hour-and-a-half flight. And all of these behaviors of the machines in terms of the way our customers use the equipment and how the industrial world uses equipment in general changes how machines age over time, changes their performance, changes how you can utilize them. And we are moving to a world where we can get into condition-based maintenance, where we can actually predict what will happen based on all the analytics that we can drive on these platforms, so that we can make decisions and our customers can make better decisions about how they utilize assets. So this is the world that we're entering into, and it's a huge growth opportunity for all of us in this community around getting the Internet of Things to work for industry. So, what do we mean by this? So just if you think about the energy space, right? So there's 1 billion smart meters going into the world. All that data that comes off of them is going to be generating all kinds of insights in consumer behavior, in energy utilization. How can we use that information to drive better outcomes? If you look at lighting, lighting is going through dramatic change just with the advent of LED lighting. GE invented the LED light fixture, and now the GE business lighting is renamed. It's called Current. And the reason why they're renaming themselves is it's a different business model. You don't sell razor blades anymore. You can't sell a light bulb that lasts 25 years and make a business out of it because your customer's already going to be gone by the time that you're ready to replace that device. And so you have to change the way that you operate. So what happens in an environment like what we're doing with the city of San Diego right now, where we're replacing all the street lamps in downtown San Diego with new LED light fixtures, and the ROI is great. Just doing the LED is about a 3-year payback on energy savings from the previous generation of lighting equipment that they have downtown. But instead of just putting LED lighting, we're adding a camera, motion detection, temperature, infrared, a whole bunch of sensors that enables the city to offer new services to the citizenry, to enable them to discern parking violations, help early responders to accidents or events. There's a whole new infrastructure that gets provided when you can connect these things together. Now you have to do it in interesting ways, and you have to do it in a secure way that makes sense so that we can protect these assets and that they don't bring harm to people. And certainly if you look at the whole connected car conversation, there's a huge opportunity around how that information gets used, how that information becomes more valuable in terms of how you design products, and how it can change consumer behavior. And just by 2020, we're going to have 10 to the 6 terabytes of data being generated by GE machines. So if you think about the volume of information there, that's pretty much larger than any other volume of data provider that you have there, Google, Facebook, or others. So the industrial world has this enormous opportunity to find insights out of the information. So what do you do to do in that space? So there's a market opportunity for all of you in this room, and in fact we have some partners here, and I'll talk a little bit about them in a moment, that we're working with in Israel, that are working in this space. So if you look at kind of the environment that we have Google that sort of solves search. And we have sort of the enterprise market that's moving towards the cloud, Salesforce, Workday, those types of environments. There's this whole new opportunity in the industrial space. Operational technology with the OT world is sort of undiscovered country. They have really not automated in the ways that you would think business has. And in the large business space and industrial sector, there hasn't been a lot of productivity gain in the last 10 years because they've done all the things that they can do in their supply chain. They've brought ERP to bear. The big new territory for them to operate on, become more efficient, more effective, to deliver better services, is in connecting their things so that they get better outcomes. So how do you do that? And what's GE up to in this space? So we're building a platform. We call it Predix. It is a modern cloud platform. It's built in a way that allows you to radically change the way that you build software. You don't have to build long projects anymore. You build projects out of small microservices, chunks of software that have code that enable you to build the applications that you want to build. Our platform is built on top of Pivotal's Cloud Foundry. If you're familiar with Cloud Foundry, it is a very interesting way to build software. It dramatically reduces the amount of time that you need to build software. But we add a layer on the top of that that's very specific to the industrial world, around security, around edge compute, around connectivity. If you think about it, you may have a device out in an oil field in a very far and remote location where having internet connectivity is actually very expensive or intermittent. So you need systems that can't just be pure cloud. They need to scale from cloud all the way down to the device. And you need to have the ability for devices to communicate with each other, share computational tasks, and aggregate information and analytics at the plant level, at the device level, at the plant level, and then all the way up to the cloud to give industrial customers the degree of insight that they need to operate their operations. and it also enable that infrastructure to be secure so that people can't hack into it and get into it. So the basic concept is pretty straightforward. You place sensors on your devices, you grab that data, you run it through a system, you have an ecosystem of partners who are building algorithms and capabilities into that platform. You build great applications, and what happens to business? Well, now they can respond in real time. They don't have to wait till the end of the business cycle to make a decision. And I'll give you an example. Let's say it's a very hot day in Atlanta. There's an opportunity in the spot power market to make a lot of money if you can have excess capacity into the system. You've got power generation capability. What if you could run your equipment at 110%? And you know that that's not good for the equipment, but you also know what that means to the maintenance window on your equipment, and you can make an economic decision and say, you know what, it's more valuable for me to run my equipment hard right now because I have a window in October where I can take it offline and do some repairs and modifications to it. And I can generate that power at a cost point that improves my margins or allows me to not have to fire up a coal burning plant or allows me to be more ductile or facile with my market space. That's the world that we're entering into with an enabled platform that allows you to connect all of your devices, all of your infrastructure, and have visibility so that you can make great decisions in terms of its utilization and how it gets deployed. So what is Predix? So Predix is a platform that's designed at scale. GE is building its entire infrastructure on Predix. We're making a huge bet. We built a new first-line organization in GE called GE Digital. We have aspirations to being one of the largest software companies in the world. We're in the top 20 right now. We are building it as an open ecosystem. We know that we can build it for our machines, but our customers run machines that are built by other industrial companies, and they want a single pane of glass to be able to visualize and understand what's going on in their environment. The only way to do that is to invite participation from a broad ecosystem, and I'll talk a little bit about how you guys can be involved with that. It's global, it's certified, provides edge to cloud security and faster innovation. So just going to go very quickly, we have a bunch of partners. We have 3 partners from our Israeli incubator here in the audience today. We have Plantain, Precog, and you guys are up there, right there, I'm forgetting. Theta Ray, that's right, my favorite friends from Theta Ray. And they're helping us build capability into that platform. And there are 2 ways that you can actually work in the Predix ecosystem. You can build services that others can consume to build applications, or you can build applications and bring them to market built on top of the platform. And you can find out more at predix.io. That's our developer site. It tells you all about it. It has all the content. We have a catalog of these kind of microservices. You'll see our partner Theta Ray down in the bottom right. They already have a microservice in the platform that's really has a powerful anomaly detection capabilities that we find really interesting. And this is proof that GE is actually building an open environment, an open door for people to operate and work on. And with that, I will finish and say there's a tremendous opportunity for people in this audience to join us on this adventure. It's a big market. We believe it's $1 trillion market. We believe that the next big, large growth in industry is going to happen in this Internet of really important things. Thank you very much.